Question number 3, part A. This is a way of writing a function. The same thing we can write. So this is the domain. X is an element of real numbers. Also, you can write minus infinity x greater than positive infinity. This one we can write as a px equal 3x minus 2. It's the same thing. And p equals 16 and px equal to 3x minus 2. Now we can see that this is PA value. So we need to put when x equal A, so P A equal 3A minus 2. If you feel like it's confusing, so let's say Px equal 3x minus 2. If we put 3 triangle, then this is going to be 3 triangle minus 2. If we put 3 star, then this is 3 star minus 2. Likewise, this is PA, then this is 3A minus 2. Or 3 times A, 3A minus 2. So now we have two things. One is PA equal 16 and PA equal 3A minus 2. Hence, this is same, right? Hence, 3A minus 2 equals 16. This is also right, 16 equal 3A minus 2. The way you can take the way is more relevant. So then this is 3A equal 18, A equal 6. Part B, QB equals 17 and QX equal, this is given. Now you want to find QB when X equal B. So QB equal Q square minus 3. Again QB equal 17. Then those two are equal. Q square minus 3 equal 17. Hence Q square equal 20. Q equal plus or minus square root 20. Square root 20, 4 times 5, square root 4 times square root 5. This is going to be 2 square root 5. So Q equal plus or minus 2 square root 5. Part 3. And when x equals c, when x value is going to be c, when x equals c, rc equal 2 to c plus 2. Again rc is 34 given. Hence this is 1, 2, hence from 1 and 2 to c 2 to the power c plus 2 equal 34 to this is 2c equal 30 more minus 2, that is 32. This is 2c plus 1. Then 2c plus 1 equal, then now 32 I can write as 2 to the power 5. Then the only possibility if this 2 and this 2, this implies that c plus 1 equal 5, c equal 5 1 minus 1, c equal 4. Part 4, as usual, when x equal d, sd equal d square plus this is x minus 6, or d minus 6 and sd equals 0, 1 and 2 from 1 and 2 d square plus d minus 6 equal 0, d plus 3 d minus 2 equals 0, d plus 3 equals 0 or d minus 2 equals 0, d equal minus 3 or d equal 2. Question number 4, part 1, we want to decide the mapping. You can draw a mapping and decide whether this is a function or not. So f1 equal to 1 times plus 1, 3. f2 equals, so this is the domain given, 2 times 2 plus 1, 5. f3 equal 2 times plus 1. f4 equal 2 times 4 plus 1, 9. f5 equal 2 times plus 1, 11. So all are distinct. 1 to 3, 2 to 5, 3 to 7, 4 to 9, 5 to 11. So 1 to 1, there is no repeat. So basically this is 1 to 1. I want to write as mapping 1, 2, 3, 4, 5 and 3, 5, 7, 9, 11. And this is 1 to 1. Hence this is a function. So reason we can write one each value of x maps to one value of y. And b, this is x and this is square root x. Also we can refer as gx. So we have 1, 4, 9, 16, 25, 36. 1 go to g1, 4 go to, we need to find, so g1 equal square root 1 equal 1. So g2 equal square root 4. It is clearly mentioned that in this sum, to consider a positive, there is a note. Remember, square root x means that positive is square root. Not always, since there is a note, so we'll consider only positive square root. So only positive square root. So hence there is no plus, so 2 answer. This is going to be 2. So G3 equal 9, 3, G16, G9, G16 equal square root 16, which is 4. G25 equal square root 25, which is 5, and G36 square root 36, which is 6. Now this is G1 is 1 and this is 2, 3, 4, 5, 6. So this is the range. 16 go to 4, 25 go to 5, 36 goes to 6. So we can see that we have only one distinct element, distinct y value for each element of x. Hence this is 1 to 1. As each value of x maps to single value of y. Part C. So this is the domain. So we'll work out h minus 2 when x equal minus 2. Uh, when x equal minus 1, h minus 1 equal minus 1 square equal 1. When x equals 0, h equal 0. 0 square equals 0. X equal 1, h1 is 1 square equal 1 and x equal 4. H2 equal 2 square equal 4. So when you look at those are the range, possible range value, and those two range values are same, and these two are same. This is x, this is x square, or you can tell this is hx, and minus 2, 0, 1, 2. Actually, we'll write in a more better way. 4 and 4 give minus 2 and 2. And this one minus 1 and 1 and 0. Minus 2 and 2. And then 1 minus 1 and this one give 1 and 0 give 0. We don't need this one. So the function is many to 1 as two values of x map to one value of y. Part D fx equal to over x, and those are the domain. F1 equal to over when x equal 1, F1 equal to 1 equal to 2 equal 1, x equal 3, if 3 equal 2 over 3, x equal 4, if 4 equal 2 over 4 half, and x equal 5 if 5 equal 2 over 5. X fx 1 to 1 as one element of x maps to one element of y. When x equal 1, k1, that is e to the power 1 plus 3, x equal to k2, e to the power 2 plus 3, x equal 3 k3, e to the, this is, okay, so 1 and 2, and there is no 3, when x equal minus 2, k minus 2 equal e to the minus 1, k minus 1, when x equal 0, k 0 e to the power 0 plus 3, when x equal 1, k 1 plus 3, and when x equal 2, k 2 equal the power plus 3. We have to use the calculator to work out. I will put the answers x and kx. We can see this is 1 to 1, 1 to 1. Every element of one element of x map to one element of kx. So range, this is the range 3.14, 3.37, 4, 5.72, and 1039. Question number 5. We want to sketch range and one-to-one normality 1. Part A, fx3x plus 2, and the domain is given x greater than 0. It means this is the number line, so this is 0. So the graph is only valid for this. So we don't need this area. It means we can have negative y's, negative and positive y's, but something like this, and positive x values only. Can we get 0? Yes. So we know this is a line, so we need 2 points. So we can take 0 as well. When x equals 0, which is y-intercept, y equal, or if 0 is 2. So 0, 2 is one place, 1 point, y-intercept in other way. And when x equal 1, I will write 0, 2. Then if 1 equal 3 times 1 plus 2, 5. So another point is 4, 5. So let's say this is 4, another one is 5. So we can sketch this one like this. And this is 2 value as a coordinate 0, 2. And so we can see that for all the 1 x value, we have 1 value, 1 y value. For 1 x value, we have 1 y value. So we know that this is hence 1 to 1. Now when you look at range means all possible y values. Y mean here it is fx axis. This is x axis. All possible fx values. Now, what are the possible x values? 2. Sorry, fx values. Y over y values 2. Then 2.2. When you put this one, you get this one. Then 2.3. We put this one 2.4, and you can see that all the values more than 2, all the y values more than 2 is going to be the range. So then range is 2, 2.1, 2.2, 2. How about 2.1 in between, 2.001? How about 2.00001? So likewise, there are infinity numbers, right, in between here also, then 3, 3.14, likewise. So instead of writing all these numbers, we simply write the range is y greater than or equal to 2. 2 also possible. So in here, we don't refer y, it is fx. So fx greater than or equal to 2. Function is one-to-one reason. One value of x maps to one value of fx. Part B, fx. First of all, we draw this graph to get an idea, then we'll apply the domain. We know fx equal x square. So this kind of graph. Then fx equal x square plus 5. It means we have to shift by 5 this graph. This is x, fx, and now this is fx equal x square plus 5. And then we want to consider the domain x equal 2 line. It means this graph, from this point onward, we need this part. So this is the how the graph should be. So we can draw the graph as from here, something like this. X, fx. The x value is this space is 2. What is the y value? So when we put f2, that is 2 square plus 5, which is 9. So this is 9. So up to here it is 9. Now the domain is from 2 onwards. This x value is 2. From 2 onwards. So what is the range now? When you put 2 onwards, all the value, what are the possible y values? So you can get this y value, this value, this value, this value. It means each and every height. So you can get. So basically the minimum is 9, and then 9 point, then 9.1, 9 point, okay, before that 0, 0, 0, 1, and likewise then 10. So up to infinity. So instead of writing this thousands of values, millions of values, infinite number of values basically, we can simply write when domain x greater than or equal to 2 and the range, the minimum value is 9, and fx greater than or equal to 9. From 9 onwards, all value is fine. So we can see that for one x value, one y value, one x value, one y value, the function is 1 to 1, as for one element of x maps to one element of y. Part C, fx equal to sin x, this is the graph. We know, first of all, just to get an idea, sin x. Sin x we do like this, 0 to, so we consider three pressures. Basically, this is 0, 0, and this is 0, 180, and this is 90, 90, and the coordinate is 91. This is 1. Now, uh, what will happen for fx2 sine x? So we'll put x when x equals 0, 2 sine 0, that is 0. Sine 0 is 0. 2 times 0 is 0. That is 0, 0. Still this point is as it is. Now, when x equal 90, so if 90, what will happen? 2 times sine 90. So 2 times sine 90 mean 1. So 2 times 1 is 2. So this is going to be 92. So now this graph instead of 1, so it is, I'll draw again, 0, 90, 180. This is 1. Now what will happen this point? It will go up to 2. Now for this graph fx equal 2 sin x, 90 mean it is here now. For this graph, this kind of graph, you can see that if 180, again 2, I will check this point, sine 180, 2 times sine 180 means 0 again. So this is 0, so 180, 0. So those 2 points as it is, this 1 become 2. So now this is the graph. This is x and this is 2 sine x graph. Also you can tell that this is fx. So this is the graph. X 2 sine x. We can see that for one y value, let's say this is y1, we have two x values, that is x1 and x2. So x1 also map to y1 and x2 also map to y2. So y1, x1 also map to y1, x2 also map to y1. So this is many to 1. As two elements of x map to one element of 2 sine x, and range is going to be any value. So those are the possible y values. Range any y value between 0 to 2. Part D, to draw this graph, we should remember this graph. I think with my discussion I show you this type of graph. Fx equal y square equals square x. When we square root, we take square root y equal alpha square root x. Alpha equal 1, then square root x. So this is plus or minus, and we only consider positive one. So this side, In here there are two types, positive and the other one negative. Only consider positive. So you should remember this one. So from here we can work now. So square root x this is the graph starting from 0. Then what will happen? X plus 2. So we know that this is the square root. So this value should be greater than 0 always. So x plus 2, what is the minimum and maximum you can take? So maximum, let's say 10,000, one value 1,000. So 1,002 plus 2,002, it is greater than 0. 1,003 plus 2,005 greater than 0. Yeah, in the number line you can put bigger values. There is no problem greater. But if when x equals 0, what will happen? 0 plus 2 also greater than 0. Okay, 0 also fine. Can I put minus 1? Yes, I can put minus 1 because minus 1 plus 2 also greater than 0 because minus 2 plus 1 is 1, still greater than 0. Can I do minus 2? Yes, minus 2 plus 2 is 0 is equal to 0 now. Still fine. Can I put minus 3? Can I put minus 3? Minus 3 plus 2 equal minus 1. So this is not defined. It means minimum value I can put x equal minus 2 and the value bigger than minus 2. That's why when you look at this one, the domain is fixed to that. So when x equal minus 2, y value is 0. So then fx equal fx, the graph is going to be like this. Square root 2. When you put 2, minus 2 plus 2, 0. So this coordinate, this place is x value is minus 2. Coordinate is minus 2, 0. Simply when we draw this kind of graph, if we have x plus a, we will bring x plus a equals 0, x equal minus a. So then graph is going to be starting from minus a. How about this one? If x plus equal x minus b. So then x minus b equals 0, x equal b. Graph is going to start from b. So now this is the sketch of the graph, and we can see that this is 1 to 1. 1 for 1 x value, 1 y value, 1 x value, 1 y value. This is 1 to 1 as one element of x maps to one element of fx. And what is the range? So range mean in this box all the possible y values or fx values. Can I take 0? Yes, I can take 0. 0.1, 0.100001, yes. 0.0001, yes. 0.01, yes. 1, yes. 1.1, yes. 1.1199, yes. So likewise, I can take any point greater than 0. So the y values, any point greater than or equal to 0 is going to be the range, because this graph go up to infinity. For this one, you should remember fx equal ex graph first. So this graph you can remember something like this. And we know that this x value is 0, this is 0, 1 coordinate. Y-intercept is 1. And now we'll apply the domain. X can't be any negative values. It means the graph is not, we have to delete all the x values. Then we have to delete the y which occur due to those x values. The graph is going to be like this. And this is 1 to 1. So when you do any x values, you can get only one intersection point. So this is 1 to 1 as one element of x mapped to one element of y, and the range is, what is the minimum of y value is 1, and can it be 2? Yes. Any y value is 3? Yes. Likewise, this graph goes to infinity. So 1, 1.1, likewise 3, 4,000, it goes up to infinity. So simply we can write, instead of writing all the numbers, infinite numbers, fx is greater than or equal to 1. 1 also possible. To draw this graph, we should know fx equal log x. This kind of graph, and we know that when x value is 1, log 1 equal 0. So the coordinate of this one is 1, 0. And x is a real number. X greater than 0, not equal to, because this is going to be asymptote. X equal 1, x equal 0, or y axis is going to be a asymptotic. So what will happen now? This y value from here to here, all the y values we want to multiply by 7. So then 1, 2, 3, 4. If I draw like this, if this is 1, so for 7 times, 1, 2, 3, 4, 5, 6, 7. This dot is going to be here. So likewise, all the dots going to be expand by 7, but still it's going to 0, because 7 times 0 is 0. So still this type of graph is going to be the high steepness. So this is fx equal 7 log x. So it is clear that this is going to be 1 to 1. uh, 1 to 1. Then we have to write each element of x map once to each element of fx, and then range is going to be, so this will go up to infinity, minus infinity, and this will go up to positive infinity. So minus infinity greater than fx greater than positive infinity. So you can write range as like this. The same thing you can write fx is a element of real numbers, because we make the Cartesian plane by keeping two number lines across with 90 degrees angle. This is another number line and this is another number line. Even it is y, it is still the real numbers. X, all the real numbers. So instead of telling that, we can tell that fx is a element of